Okay, let's try this. My voice is discouraged because look at it, I already did it all, but I hadn't turned the microphone on. So I'm going to do it again. So what we're doing is a little introduction to chapter, if you will, chapter 3, section F, right? 3F, exponential functions. So in other words, when you hear functions, usually you're thinking some types of graphs. We're going to do some graphs. So you know the most basic exponential function that everybody's vaguely familiar with is y equals b to the x, right? And you can tweak it a little bit. You can make it, so just for example, let's make the very basic one when b is 2. So that's y equals 2 to the x. So it's an exponential function because the x is in the exponent, right? It's in the power. That's different than y equals x squared. Now that both of them, they both grow, right? They both grow as x gets bigger. Because x squared, because like if x is 1, x squared is 1. When x is 2, x squared is 4. When x is 3, it's 9. So this one grows. This one grows, but it even grows faster because when x is 2, it's 4. When x is 3, it becomes 2 times 2 times 2. When x is 4, it becomes 2 times 2 times 2 times 2. So depending on what the b value is, if I remember right, I'm just kind of thinking off the top of my head, I think this one, this one may grow a little slow at first, but over time it will crush this I think is called the power function, and this is the exponential function. I think it will rapidly pass the other one with a little bit of time. But if that value of b is even bigger, let's say it was like y equals 9 to the x, it'll grow even faster. It'll go really rapid. So just to verify, let's just look at it. We'll just graph it real quick. This is coming from the book. You just to pick a few numbers, like x is negative 2. What happens to y? Well, that'd be 2 to the negative 2. So that'd be, remember how to do that? You got to put it like that. Got to put it over 1, under 1. So it'd become 1/4. When x is negative 1, that'd be 1 over 2. When x is 0, and that's interesting, when x is 0, it's going to be y's 1. So that's the interesting thing about this graph. When we graph it, let's look at it. You can find the y-intercept. It's always going to be, typically the most basic one, it's always going to be right there. Because when x is 0, whatever you raise your base to, whether it's 2 or 3 or 4, it's always going to go to 1. So that's kind of cool. And then what's happening here is the x is getting negative. You're getting smaller and smaller fractions, never quite making it to 0. So it's an asymptote. It gets closer and closer, and then on the other side, of course, it's going to blow up. When it's 1, it's going to be 2. When x is 2, that's going to be 2 times, that's 2 squared. When x is 3, that's 2 times 2 times 2, that's 8. So it's going to start to grow pretty rapid, boom, and start to expand out. That's your exponential function. That yellow one went right through. What they do now in the book is they have a little investigation, and depending on your discipline level, you might want to do a couple of these investigations, because they're making little changes to this basic equation, this basic function, and they're seeing how that affects it. Like the first one they say is, like you're changing the base value, you're changing the b. So we already know that. Like if you have the difference between y equals 2 to the x and y equals 10 to the x, the 10 to the x is going to grow quicker. But then they do other things like, well, what happens if you say y equals 2 to the x plus 3? What does that do? Or y equals 2 to the x minus 2. And what you'll find out is that changes the asymptote. That's going to make the asymptote move up. The horizontal asymptote is going to move up. So you could play with a couple of those. I think it's not a bad idea to do a few. And then it brings you down. I'm just scrolling down. I'm on page 110 now. Then it brings you to the very generic function where you have several variables, and you know how each variable affects that function. Like what happens if you have a constant in front of the base? You have an a value. What happens if you take whatever your x is and you subtract off something? In this case, I put 3. It really should be c. minus c. I should make all the links. That will change. This will, if you have different b's, if you have different d's. So based on those little changes, it will shift your function a little bit, which all allows you to draw sketches pretty quickly. And that's all you're going to do is practice drawing some sketches. And then one thing they're going to introduce is kind of cool, is if you have a pretty good sketch, you can actually solve some basic equations off of the sketch just by reading the sketch. So I'm not even going to try to show you an example. I want to encourage you guys just to dive into it, do a few of those investigations, and then just try the problems. Sarah already did them all. She did them without any video help. So I'm gonna assume it's not going to be too crazy hard. So, but if you get stuck on any ones, just shoot me a message, and then I'll do a couple videos if needed to help you. But I think this section's going to go pretty well. Hopefully, it's only 6 questions, with a few. So let me know if you need any help.